We're doing Learning Target 17 in class today, which is about the graphs of inverse trig functions. So before we do any of those, we're going to go through and just talk about inverses for a second. So for example, if I have the equation y equals 3x plus 2. This is not on your packet, but this is just to think about what this is.
Like an example?
Yes. So 3x plus 2 is just a line, right? And I can make a table of values to get what was in, like what was the points on the line. So I could have negative 1, 0, 1, 2. And I can substitute those into the function. So negative 3 plus 2 is negative 1. 0 plus 2 is 2. 3 plus 2 is 5. And 6 plus 2 is 8. Okay? If you want to do an inverse, you change the place of the variables. You flip-flop them. So I'd have x equals 3y plus 2. You still have to have y equals to have an equation, though. So to solve for y, so y equals x minus 2 over 3. That's the inverse of the equation over here. And so if you make a table now, if I flip-flop the x and y sides, then all of these values would hold true with this inverse function. So negative 1 minus 2 is negative 3, divided by 3 is negative 1. 2 minus 2 is 0, divided by 3 is 0. 5 minus 2 is 3, and 3 divided by 3 is 1. And 8 minus 2 is 6, and 6 divided by 3 is 2, right? So an inverse function, you're just taking the variables and flip-flopping them, and so it ends up changing the points to be the opposite of what they were to begin with. Does that make sense? That is what an inverse does. So we're going to do that today with sine, cosine, and tangent functions. I'm going to do the sine one with you. Then you're going to do cosine and tangent on your own in class. So we can go over them and make sure you did it right. Okay? So, sine, number 1 on your packet, it says, graph sine below. We have graphed sine about 1,000 times. Just look regular sine and nothing is happening to it. So where do you put the first point for sine? 0, 0. At pi over 2, where is our point going to go? 1, and then 0, and then negative 1 and 0. For the sake of this packet, we're going to go through and do the other side as well. So negative 1, 0, 1, 0. Everyone go with the sine function. I've done it a million times. What's the domain for sine? All real numbers, because every single x value could be used. What's the range for the sine function?
Less than or equal to 1, but greater than or equal to negative.
Right. Y has to fall between the boundaries of negative 1 and 1. Questions about domain and range? Well, that says the inverse x equals sine y. So if we invert the variables, sine is called arc sine. We talked about that way back in Unit 1, that has its name. That's the same thing as the key in your calculator, right? Arc sine is the inverse sine function. Questions so far? Well, it says on 4 to graph the inverse relation y equals arc sine. If we're going to graph arc sine, always a good strategy is to make a table so we can flip the x and y to make the points for the next one. So for example, I have a point at 0, 0, point at pi over 2, 1, a point at pi, 0, and 3 pi over 2, negative 1. So if I'm going to graph the inverse, then I'm going to flip all of those. So I still have a point at 0, 0. Then I have a point at 1 pi over 2. A point at 0 pi. I have a point at negative 1, 3 pi over 2. And you could continue the pattern from there. Be careful. I know it's very tempting to flip your graph on the side and just do what you did for the first graph, but be careful because that will probably lead you astray when you do tangent today. Make sure you're looking at the points that exist. What's the domain for arcsine? Nope. Right, it's the range of what sine was. If you flip off the variables, the domain and range are inverted. The domain is x is bounded by negative 1 and 1, right? The curve keeps going between negative 1 and 1 and doesn't go beyond that. So then what's the range? All real numbers. Because every y could be used. Questions so far? All right. So on number 6, it says, is the relation y equals arcsine a function? Is this a function? How do we tell if something's a function or not? It's not a function y. Right, the vertical line test. Right? This fails the vertical line test pretty much at every point. Right? You hit infinite number of points because it keeps going. So this is not a function. Because it fails the vertical line test. And number 7, it says, is it possible to define a new function from the graph of y equals sine x whose inverse is a function? That's a weird question, and I don't expect people to answer it the way it's written. All it's saying is, if you go up to sine, could you take a piece of it and then do the inverse so that the inverse was a function? So could you just take a piece or take a chunk out that then the inverse would be a function? And the answer is yes. I could just pick a section. As long as you do the section appropriately, then it won't repeat itself when you do the inverse, and so you won't fail the vertical line test anymore. So the mathy way of saying that is yes. We could restrict the domain, right? Right now the domain of sine is all real numbers, and that obviously didn't work. So if we pick a subsection of that, maybe it would. So we're going to be flipping back and forth here for a second between the back of that page and the front of this page. So on the back of that page, it defines that new function for you. It is possible to get a new function called sine whose inverse is a function. Please take note of the capital S, because that's the only way you're going to differentiate the two. Okay? Sine with a capital S only has a domain from negative pi over 2 to pi over 2. So it's not all real numbers. We're going to just pick out that little section. So the capital S is actually important because that means we're only looking at a single section instead of the whole curve. So it says that the values in the domain are called principal values, and that's what we're going to talk about tomorrow in Learning Target 18. Okay? So 8 says indicate the graph of y equals capital S sine on your graph. So if you flip back to your graph, we're going to make a box around the part of the function we're actually looking at, right? We're restricting the domain to negative pi over 2 to pi over 2. Then I'm just looking at this subsection of the curve. Does that make sense? It defines section for you, negative pi over 2 to pi over 2. So we're just marking that on the graph that that's what capital S sine is. So lowercase s sign is the whole curve that keeps going, and capital S sign is just the part in the box. Questions about that? Okay. So the domain then for capital S sign is just what has been defined for you. Negative pi over 2 to pi over 2. But the range is still all real numbers. Scratch that. The range is not all numbers. The range is still negative 1 to 1. Sorry. Questions about that? So if we do arc sign with a capital A, that's going to be a function now because it's that one little piece. So if you flip it on the side we did the inverse like we looked at, then it should be that one little piece. So we talked about the inverse is the domain and ranges. Just change around, right? So we have negative 1 to 1 for x like it was before. But now the range will be from negative pi over 2 to pi over 2. And we're going to go back and put that on our graph as well. So once we fill it in, we can go back and we'll mark which part is capital A arc sign. So the range is from negative pi over 2 to pi over 2. So again, this part is just capital A arc sign. That's going to be important tomorrow when we're learning target 18. Okay? Because maybe I say, we're talking about sign, just sign. Okay? If I say to find sign with a capital S of pi, you can't do that, right? Pi is over here, and that's not in the domain of sign with a capital S. So we wouldn't have an answer there. All right? We talked about sign of pi with lowercase. Well, we know what sign of pi is with lowercase because it's that point. So it's going to be important tomorrow you know the difference between capital S and lowercase because maybe you won't be able to get an answer or you have to look at a specific set of values. You won't be able to look at everything. So we're going to use our unit circle tomorrow. So you won't be able to use the entire unit circle, right? Because the unit circle goes from 0 to 2 pi. We're only going to be able to look at negative pi over 2 to pi over 2. That makes sense. All right, so we just need to make sure you're looking at this tomorrow when we go through this. You have to look at those sections. All right. The rest of this is slightly repetitive. So in class today, you guys are going to do cosine, which is the next page. You're going to graph cosine. You're going to graph arc cosine. And then you're going to go through and it's going to give you the definition about capital C cosine. And you're going to mark it. And they're going to give you a definition about capital A arc cosine. And you're going to mark it, all right, and do the domain and ranges. Okay, again, it tells you what the subsection is, so you don't have to guess. Then you're going to do tangent on the next page. I want you to be cautious about tangent. What is the period for the tangent curve? Pi, right? Pi over k. So just regular tangent is just pi, right? On all of these graphs, they're all the same, and they all have intervals marked out for 2 pi. So when you graph tangent in a little bit, we would do pi and divided by 4. We'd have a scale of pi over 4. So we need to be using all of these points in between as well, right? We're going to have to use these, not just the ones that are given to us. If not, your tangent curve will be too wide. Okay, so you have to count by pi over 4. Also, we will do the domain and ranges together at the end of class because the domain is kind of confusing because of all the asymptotes, right? So we'll talk about that together at the end of class. Right? You can do the capital T and lowercase and capital A arc tangent. But the domain and range for lowercase t will be kind of confusing. We'll talk about it. I'm going to give you about 20 minutes to do the cosine pages and the tangent pages, and then we're going to go over it to make sure you have the right answers so that you know what you're doing tomorrow. At the end, you need to do this last page. It's just all the stuff you already have, just put into one table. Like we already did capital S sign and capital A arc sign. We did the domain and ranges already. So you're just going to recopy them from those pages onto this page. And then the very, very last page, the back of your packet, we're going to do tomorrow. It's only target 18, so you don't have to do that. But I expect you to get the rest of it done and have questions before the end of class.